This is a video key for Rational Expressions, Advanced Skills, Chapter 10. So the first one is simplify the products and quotients using the strategies developed in the basic skills. So we have 42 over 30, which has a common factor of 6. So if we reduce those by dividing them each by 6 or crossing out a factor of 6 over 6, that's going to reduce to a 7 and a 5. Then we have a factor of x and 4 factors of x in the bottom. So writing it out long would mean one of these would cancel with 1 from the bottom. So I have 7 over a 5, and then this factor of x cancels out, which leaves me with just 3 factors of x in the denominator. And then we have 3 factors of x plus 2 in the top and only 1 in the bottom. So this one cancels out 1 from the top, which leaves 2 from the top. So the final answer would be 7 times x plus 2 squared over 5 times x cubed. Let's go across. So since it's multiplication, we do not need to rewrite it. So we can think of it as being rewritten like this. And I could do this 2 ways. I could either multiply the 4 times the 12 and the 3 times the 14, or I can start breaking down the factors before. So my preference would be to break down these factors. So I'm going to cross out this 4 and this 14 and reduce those by a factor of 2, which makes this a 2 and this a 7. And then I could reduce this 12 with this 3 by dividing them both by 3. So this 12 would become a 4 and the 3 would become a 1. So now I have my factors, my coefficients reduced all the way down, and so my reduced coefficient in the top is 2 times a 4, so I have an 8, and then in the bottom I have a 7. And then I have one more common factor here, so I have a 2x plus 1 in the bottom, and I have 2 factors of 2x plus 1 in the top. So this one's going to cancel out one of these. So I'll just have 2x plus 1 in the numerator. And then the other factors do not cancel out, so you'll also have a factor of x plus 3 in the top and a factor of x plus 4 in the bottom. The third one. We can reduce the 8 and the 4 to just a 2 over a 1. We can reduce the 21 and the 15 by dividing them by 3. So I can make that a 7 and make that a 5. And also keeping in mind that this was a negative here, so now my coefficient in the top is negative 14. And my coefficient in the bottom is 5 times 1, so 5. Then I want to take stock of my factors of x. So I have 1 factor of x in the top and 5 factors of x in the bottom, which is going, after canceling, I'm going to have 4 factors of x in the bottom. And then I also have y squared and y squared, so those cancel completely, and this reduces to negative 14 over 5x to the 4th. Okay, this is a quotient, so I need to rewrite it as a product to begin, but one thing we can do now is we can cross out these x's right here. So we can say that this is going to be 2 times x minus 3, pen is dying, over, let's get a new one, make sure it works. Okay. Over 3 times x plus 1. And we're going to change the division to multiplication and then flip the second ratio upside down. So we'll have 5 times x plus 4 in the top and 6 times x plus 1 times x minus 3 in the bottom. So we've just rewritten it as a product, and we had canceled out one factor of x. That was an easy one to just cross out. And so now I see a common factor here that can cross out. And then as far as the coefficients go, 2 and 3 don't have common factors, neither do 5 and 6, but if I look to the 2 and the 6, I can divide those both by 2. So I could cross out this 2 and make it a 1 because I'm dividing that by 2, and I'm going to divide the 6 by 2 and get 3. So then I have 5 times x plus 4 in the top, and I have 3 times 3, which is going to be 9, and then I have 2 factors of x plus 1 for x plus 1 squared. Okay. Example 2 for the advanced skills is to factor before multiplying and simplifying. So I am going to be looking for a greatest common factor as the first step of factoring. So 6x squared and negative 12x, those have a GCF of 6x. And the remaining factors would be x, and in the second term a negative 2 over, no common factors, but it is a quadratic, and it's a quadratic with a leading coefficient of 1. So like we talked about in the basic skills video, we're going to practice just thinking of this as simply a diamond problem that can take us straight to our factor. So what multiplies to 8 and what adds to negative 6? That would be a negative 4, giving us the factor x minus 4, and a positive 2, giving us the factor, nope, just kidding. They're both negative. It'll be negative 4, negative 2. Then you can cross out x minus 2, and your remaining factors are 6x over x minus 4. Let's go across to this one. So I'm recognizing there's no GCF, but I'm also recognizing this as a difference of perfect squares, or diffs of squares, if you will. And I know this is going to factor to x minus 2, x plus 2. Real quick, if you're not familiar with that factoring pattern, you would be looking for what multiplies to negative 4 but adds up to 0, which is going to be a negative 2 and a positive 2. And then in the bottom, we have a GCF of x. So this would factor to x times x minus 2. Then we can cross out the x minus 2 factor, and we have x plus 2 over x. Third example, no GCF, but we can factor this quadratic. 2, we're looking for what multiplies to negative 2 and adds to negative 1, which would be a negative 2 and a positive 1. And since we have a leading coefficient of 2 for our x squared term, we're going to need a little rectangle here to organize. So 2x squared, negative 1. The split is negative 2x and 1x. So 2x goes here, x, 1, and negative 1. So the factors are 2x plus 1 and x minus 1 for the top here. and the bottom factor is x plus 1. And you cannot cross anything out. So you can just leave that the way it is, or you could say that the original answer is also the answer. So we factored it, but it didn't really help us cancel out anything. But at least now we know that it cannot be simplified. Okay, looking for a GCF. The top has a GCF of 5x. So every single thing has a factor of x. So if we take out a factor of 5x from each term, that leaves us with x squared plus 4x plus 4. And in the bottom we have 10 and x squared. So since it's easy enough, I'll just write it out as x times x. Then I can cross out this x and this x. And I can reduce the 5 and the 10, making this cancel to a 1, and this 10 cancel to a 2. Then the top is a quadratic, x squared plus 4x plus 4, which has the factors x plus 2 and x plus 2. And the bottom factors remaining are 2x. So you could leave it like that, or you could say, running out of space, you could also write that as x plus 2 in parentheses squared over 2x. Alright, so this one's a little different. We are multiplying 12 times the quantity 5, 6 plus x plus 1 over 4. And we can't add these together as a first step because they don't have a common denominator currently. But the idea here is that we can distribute this 12 to both of the things inside the parentheses. And when we do that, so a 12 is the same thing as a 12 over a 1, right? So when we distribute the 12, we're only going to multiply the 12 times the numerators of the fraction. So for now I'm just going to rewrite this as 12 times 5 over 6, and then plus 12 times x plus 1 over 4. So I've just taken the 12 and I've inserted it as a factor to the numerator of each of these fractions. And then the idea is to reduce each of these fractions. So the 12 and the 6, I could cross out 12, and if I'm dividing it by 2, that would leave me with a factor of, wait, no, I can divide them by 6. So that would give me a 2, and this would become a 1. So essentially this whole first term has become 2 times 5 over 1, so that would be 10. Plus, a 12 over a 4 reduces to a 3. And then the x plus 1 is still in the top. So again, this is like 3 times x plus 1 over 1, but I'm not going to write that. And then if I just clean this up a little bit, I can multiply the 3x, or the 3 times the x and times the 1. So I would get 10 plus 3x plus 3, which is 3x plus 13. Which doesn't get more simple than that. Let's try another one like this. So we're multiplying 3x into the numerator only of both of those fractions. So 3x, I'm going to go ahead and multiply them together this time instead of leaving them as separate factors. So 3x times 2x is 6x squared over 3, because 1 times 3. And then we're going to multiply 3x over 1 times 1 over x, because I've already brought my negative over here. So that would be 3x for the numerator over x. 6x squared over 3 reduces to 2x squared. And 3x over x just reduces to 3. So the whole thing is equal to 2x minus 3. This last example is a bunch of factoring with all 1x squared coefficients. So you should be thinking about what multiplies to the last term and adds to the middle term, and that's how your factors are going to split themselves up. So the first one on top, this factors to x plus 1, x plus 1, or x plus 1 squared. The one below it factors to x plus 3, x plus 1. And then it's multiplication, so I'm just going to keep going. This one on the right factors to x plus 3, x plus 3. And the one below factors to x plus 2, x plus 1. Oh boy, this is going to be fun. Okay, cross that out, cross out those, cross out those. So remaining factors, x plus 3 over x plus 2. That's the answer. So we got to continue this key on the next page. And on the next page you have a big old box that explains very nicely how to process a fraction buster. So you can read that, ask your teacher if you have questions about that. But for this key, we're just going to work out these answers. So number 3, solve the equations using fraction busters. So we want to think about a factor that we could multiply the entire equation by that would cancel out the denominators of 3 and 2. So it's kind of like the common denominator of all these fractions. What would it be? So it's going to be 6. And it's also helpful to think about that 6 is the same thing as 6 over 1, so that we remember we're only going to multiply the 6 times the numerator of each of the items that's in the equation. So 6 times 5x is 30x, and that's over 3. And then 6 times 15 is 90, which is over 2. 6 times 5 is 30, which is also over a 2. And then we're going to reduce those fractions. So 30x over 3 is like 30 divided by 3, so that's 10x. 90 divided by 2 is 45, and 30 divided by 2 is 15. You can subtract 45 from 15, and that's going to be 10x equals negative 30, so x equals negative 3. All right. Here's a new one. So in order to be able to simplify denominators of 4, 6, and 3, we're going to need to multiply the whole equation through by 12. I'm going to write 12 over 1 just as a reminder. So 12 times x over 4 is 12x over 4 minus 12x over 6 equals 24, because 12 times 2, but over 3. Then simplify your fractions. So 12x over 4 is 3x minus 2x equals 8. 3x minus 2x is 1x, and it solved itself. Yay. X equals 8. Okay. So this time we only have one denominator, which is x. So if we want to cancel out a factor of x in the denominator, we're going to use x as our factor for the numerator. So everything in the equation is getting multiplied by x over 1. So then we'll have x times 5, which is 5x over x, just going to write it over here because I won't have enough room. 5x over x minus, and then, okay, so this time maybe think about 2x being over 1 and 3 being over 1 since they don't have denominators. So that's going to leave us with negative 2x squared over 1, which doesn't really matter, and then x times 3 over 1, so 3x over 1. I just didn't want you to get confused about where your numerators and denominators were. So then 5x over x can be reduced to 5. So really what we have here is we have 5 minus 2x squared equals 3x, which we have an x squared term and we have an x term. So yep, it's a quadratic equation, so we're going to have to use a quadratic solving technique. So we can bring all of the terms to one side and have it equal 0 to see if we can factor it. So I'm going to send the x squared over to be with the x and also keep it positive. So let's have, it'll be 2x squared plus 3x, and then it'll be a minus 5, all equals 0. And we can try to factor this. Does something multiply to negative 10 and add to 3? Because we're looking at our a times our c here and then our middle term. And yep, it can. 5 and negative 2. So complete your factoring. I use what's in my diamond problem to be the split here of how I'll split up my x terms, and then that means 2x is here, x is here, 5 is here, and negative 1 is here. So my factors end up as 2x minus 5 times x minus 1 equals 0. And then I'll use the zero product property to solve for the two answers for x here. So for this one, I would flip the 5 over and divide by 2. So x equals 5 halves, and here x equals 1. Wait a second. I goofed. That can't be. This is 2x plus 5, and I just wrote minus 5 right here. Okay, so that's 2x plus 5. And then this is a negative. Negative 5 halves and positive 1. Okay. Our denominator is x minus 2. And that's the only one. So we're actually going to use x minus 2, that whole factor, as our fraction buster. So x minus 2 gets put in the numerator times x plus 3, and that's all over x minus 2, plus 2 times x minus 2 equals an x minus 2 times an x plus 5 over an x minus 2. Whoa, you can't see. Okay. So I've rewritten the equation with an extra factor of x minus 2 in every term in the numerator, which then in the first term it's going to cancel out, and then the term on the other side is going to cancel out. So now, rewriting this, I have x plus 3 plus 2 times x minus 2 equals x plus 5. And that is a beautiful linear equation. So we can get to work. If we distribute the 2, then we have 2x minus 4. Combine the like terms, 3x minus 1 equals x plus 5. And then I can bring this over and subtract it, and I'm going to get 2x equals 6, so x equals 3. 2 more examples. Be thinking, what can we multiply this by to get rid of a 9, an x, and a 3? So a 9 will do it for the numbers, but then we also have to get rid of an x. So if we use 9x as our fraction buster, that should work. So then we would have, for our first term, 9x squared over 9 plus 9x over x equals 18x over 3. This is going to be another quadratic. So reduce the first term, the 9's cancel, and we have x squared. Cancel out the x's, and you have plus 9. And 18x over 3 is 6x. So we have another quadratic. So I'm going to bring my 6x over and stick it in between. So I'll have x squared minus 6x plus 9 equals 0, which can factor. So if I factor it, it's x minus 3, x minus 3, which is the same factor twice, so it's x minus 3 squared. But when I use the zero product property, regardless of which factor that I use, I'm going to get the answer x equals 3. Last one. Okay, so I have a factor of x plus 5 and a factor of x minus 3, and then I have a quadratic. So I'm probably interested in what the factors of this quadratic are, so let's factor it. What multiplies to negative 15 and adds to 2? Yep, okay. This would be x plus 5, x minus 3. Which is kind of cool because we already had an x plus 5 and we already had an x minus 3. So the fraction buster is going to be both the factor x plus 5 and the factor x minus 3. And I don't have a lot of space here, so I'm going to see if we can talk about this without writing out the intermediate step, because this would be a lot of writing, but really what's going to happen is a lot of this is just going to cancel itself out. So let's think about what would happen if we multiplied x plus 5, x minus 3 by 2 over x plus 5. What is going to get canceled out in the first term? It's going to cancel out the x plus 5. So that means the first term we're going to end up with a 2 and an x minus 3. So the first term reduces to 2 times x minus 3. Plus, let's think it through. What's going to happen when we multiply the x plus 5 and the x minus 3 times this whole middle thing? This x plus 5 is going to cancel out this x plus 5, and this x plus minus 3 is going to cancel out this x minus 3. So all of this is going to be gone, and it's just going to be 3x. So cool. And in the last term, on the other side of the equals, the x minus 3 will cancel. So we'll still have a 4, and it'll be multiplied by an x plus 5. So we have equals 4 times x plus 5. Oops. And it's linear, so here we go. 2x minus 6 plus 3x equals 4x plus 20. 5x minus 6 equals 4x plus 20. Send the 4x over and subtracting, it's going to be x, and then take the negative 6 and add it over, it's going to be x equals 26. And that is all of the advanced skills. Make sure to ask your teacher if you have a question about any of these problems or if they can be done a different way.